Okay, so for question one, of course, the answer is going to be photolysis or photoionization, because after those processes, the electrons obviously lose energy, which powers things like photophosphorylation. In question two, okay, so it's told you that A is 4 times bigger than B. If A is 96 micrometers, then of course B must be a quarter of that. So 96 over 4, that equals 24 micrometers. Why don't we use 250? Well, of course, it tells you that the length is 250 and the width is 96. Now, of course, as you can tell in the diagram, that the length is, of course, a lot longer than the width. So we take the width as 96. Now, if B is 24, we can see that there are 3 chloroplasts. So if we divide 24 by 3, what we end up with is we get 8.0 micrometers. Now the reason why we must write 8.0 is because it says give your answer to an appropriate number of significant figures. We find the number with the least amount of accuracy, which is 96 micrometers, and we put it to the same significant figures. So 96 is 2, so we put it to 2. Okay, so this is where it gets slightly harder. So question 3, they found that on average, that on average an algae cell had 15 chloroplasts. By assuming that the chloroplasts are cylinders with a height of 3 micrometers, what's the total volume taken up by the chloroplasts in a cell? Okay, so it's told you to assume that it's a cylinder. The reason why, it would probably be more like a sphere, but of course that might be a bit too much of the biology spec. But anyway, the volume of this is given by V equals pi r squared h. Now pi r squared simply works out the volume, the area of the circle on top, and the h is just this bit over here. Now it's told you what h is. It's told you that h is 3 micrometers. So essentially all we're going to do is work out the area of the circle and then multiply it by 3 times 10 to the minus 6. So V equals pi 4 times 10 to the minus 6 squared. Now you might be thinking, how did we get 4 when previously we worked out 8? Well, if you have a look, it says work out the average diameter. If the diameter is 8, then of course the radius is half the diameter, so the radius is 4. Okay, so pi times 4 times 10 to the minus 6 squared, and then we have to multiply by the height. The height is given as 3 times 10 to the minus 6. And this equals so this equals 1.508 times 10 to the minus 16 meters cubed. Now what you have to understand is that that's the volume of one chloroplast, not 15. So if in a cell there are 15 chloroplasts, then the total volume taken up by the chloroplasts will be the volume of one cell multiplied by 15. So if we do 15 times 1.508 times 10 to the minus 16, you get 2.26 times 10 to the minus 15 meters cubed. Some people might miss this last bit, but it's very crucial because up until now we've only worked out the volume of one of these cylinders, not 15. Okay, so question 4. In an algae plant, the density of cells is 3.704 times 10 to the 10 cells per gram. For every 3 times 10 to the minus 4 meters cubed of chloroplasts, 6.59 times 10 to the 5 electrons are produced. How many electrons would 0.1 kilograms of algae cells produce? Okay, now of course question 4, it should naturally lead on from question 3. And in question 3 it's given us the total area of chloroplasts in a cell. Now we can't work out the total volume of chloroplasts if we don't know how many cells there are. So to work out the number of cells, we do we can do 100, because remember this is in kilograms, this thing over here, and that is in grams, so we have to convert one to the other. So 100 times 3.704 times 10 to the 10, and that ends up as And that ends up as 3.704 times 10 to the 12 times 10 to the 12 cells. Okay, so the reason why we multiply them is because that is cells grams minus 1, and if we multiply it by the number of grams we have, minus 1 and grams minus 1 and grams cancel, so we're left with just cells. Okay, so now that we have the number of cells, we can actually work out the total of volume of chloroplasts. Now, if you look, this is volume in one chloroplast. So to find that volume in this many, we just multiply these two numbers together. So if we do 3.704 times 10 to the 12 times 2.26 times 10 to the minus 15, we get 8.371 times 10 to the minus 3 meters cubed. Okay, so if you're following so far, that's good. But the next part is the ratio. So in the question, it's given us a ratio. So the volume to electrons. Now volume is given us as 3 times 10 to the minus 4. And electrons is given us as 6.59 times 10 to the 5. So we just basically work out like normal ratio. So we do 8.371 times 10 to the minus 3 all over 3 times 10 to the minus 4. Because remember, you might have remembered from GCSE that to use ratios we have to work out one part. To work out one part we have to divide by its own one. So that ends up being 27.903. Now to work out the electron, so actually we've now got 27. Let me write that. We've now actually got 27.9 parts of this. So of course we must have 27.9 parts of this. So if we do 27.903 times 6.59 times 10 to the 5, we end up with 1.839 times 10 to the 7 electrons. And that's our final answer.